MedBix Webcast is a new kind of healthcare media channel to break the silo mentality and foster interdisciplinary thinking. Our mission is to fill that gap and to create a curiosity through different lenses, tapping the passion that guided the historical figures in medicine and bringing present-day groundbreaking research to the front lines. We interview physicians and leaders in the industry about present-day healthcare challenges on our live programming. Welcome to the MedBix Webcast. This is Ramana Annamaraju. I'm the host. No, I'm not Albert Einstein, but I have a guest speaker joining from where Albert Einstein is from, Munich-Germany. He's joining. Actually, it's going to talk about, so right now there is a lot of noise going on around ChatGPT, all the AI kind of algorithms, ChatGPT, BOD, and a few other artificial intelligence algorithms are coming up. Everybody is talking about it. We want to know what is the implications of those algorithms in healthcare. That's one of our interests. My media channel is healthcare channel. So we're going to talk about that with our guest. His name is Rudolf Wagner. He's joining from Munich, Germany. He's a global director for a Huma company, and he has extensive experience in regulations for the submitting probably medical devices, now medical algorithms, software, medical software as a device, SOMED, software as a medical device. He calls it SOMED. So there is a lot of new things coming up. We can learn from him a lot. So let me bring him to the stage. Welcome, Rudolf. Welcome to the MedBix Webcast.
Yeah, thank you very much. It's an honor and pleasure to be with you, Ramana. Hello.
Thank you. You're joining from all the way from Germany. Sorry to wake you up in the early morning for you, but
that's true.
I wanted to ask you, there's a lot of, you have quite a bit you wrote in LinkedIn, a lot of articles you wrote about AI algorithms and the implications of the healthcare. Tell us, what are the AI algorithms AI is doing? What are they? Which ones are more popular now in the healthcare area, at least? Can you give us some kind of a background of the AI?
Yeah, absolutely. I mean, there is, of course, the large language models and what everybody is basically currently using for different kind of usage, ChatGPT, but also BOD. We have heard from Google in the last couple of weeks about their new MedPalm 2 algorithm, which passed the medical exams. So there are these large language models which are for general purpose, but then we have also, and that mainly goes a little bit under the radar, already approved and appropriately compliant algorithms, for example, for analyzing X-rays. We have algorithms which can detect multiple physiological parameters. And there's now a huge difference in the AI space between general use AI tools and algorithms which are not dedicated to healthcare and which are not compliant to the regulation. And we have these very dedicated healthcare algorithms which are approved, which have FDA approval, which have CE mark, and which are very specific, and where you already know what they are trained for and what they should be used to. And I think there's a little bit the problem that especially these general AI tools, they are not dedicated to healthcare. So we don't know actually what they are trained on, what they are capable of, and where are the limitations. And I think that's currently a little bit, the very fragmented picture in the space, in the digital health space, which I'm sure we will talk about in depth later on.
So let us talk about a little bit of positive things. What are the great positive things now AI is helping in the healthcare specific? You just mentioned X-rays, some of the things. What are the specific things physicians, patients, or the in general healthcare systems can benefit from AI?
I mean, I said it already, the already approved and compliant to the regulation algorithms are mainly on digital imaging. There are a few algorithms which are which can, based on different physiological parameters, your pulse, your blood pressure, your BMI, your glucose values, for example, which can predict risk scores. So these are already existing and approved AI-based algorithms. Which basically will help in diagnosing or treatment. In future, I think when we look into generative AI, when we speak about self-learning algorithms, I think we will see, when we think about Corona or COVID-19, these AI tools would be able to detect trends or pandemics much earlier, because when they constantly train themselves on new developments, they will be detect signals much earlier. I think what we will also see is that the patient-doctor communication or patient-physician communication will be facilitated with these AI tools. And I think in general, when we think about when we think about health equity, so that everybody has the same access to healthcare, I think there we will see a lot with AI tools, so that everybody basically has easy access everywhere in the world to the same level of diagnostic tools, of treatment advice. I think that's what we will see in future.
You mentioned just now AI pandemic prediction. AI, before I'm in Silicon Valley, sometimes there is a lot of noise in the AI, even before the pandemic. But today, AI did not predict the pandemic. 7 million people died. There is a criticism about AI. The really, when the time comes, is really saving us or not. It is a questionable. We have to. The journalists in the United States did not question that, but I think they don't have the understanding of the AI. So why these AI models did not predict, or they're not sophisticated enough at that time? What are the limiting factors they could not predict the AI in the pandemic, deaths of pandemic and the spread of the pandemic?
I think there were two elements. I think that was the first time since the Spanish flu the world has faced actually such a pandemic in such a enormous and tremendous global reach. So the data and the models were during COVID-19 always a few weeks behind the actual development. So the data got available after the event happened. And I think what now happened with COVID-19, we have now trained AI models to detect early signals. And in future, when people use AI tools on their smartphones, on their apps, there will be much more data available in real time. And I think that was also missing during COVID-19, because people went with early symptoms to their doctors, which at the beginning of the pandemic, many have maybe misdiagnosed as a flu because the tests were not there and everything. So at the beginning, the data quality was not so good, and it was decentralized. It was offline. And you asked me about the future. I think in future, when we are used and have approved AI tools on our smartphones with maybe some sensors attached to it, the data will be in specific AI algorithms, in AI tools available in real time, so that we have two effects. We have now learned a lot from COVID-19, so the algorithms have been pre-trained, and the data will be online available in real time worldwide. And I think that will help to have better AI tools and a much earlier signal detection when a new pandemic might arise. And we hope not.
I love AI, and I'm also skeptic of the AI. For example, I use in some of these popular ones, and then sometimes it did not recognize the difference between the physicist and a physician. It's assigning a medical degrees for the people who do not have even a degree. They doubling down on me about the degrees they don't have.
It was a big problem in the beginning. I saw that in these popular ones you're mentioning. I think that giving and if you build a model on those kind of a wrong facts, it could be a dangerous model, could be in the future. Don't you think that is a danger to the AI? What
Oh,
are the
absolutely.
tell me about the skeptics of the AI like me? How do you say, what do you say?
I would say I'm team skepticism, right? We have the team hype in AI, and I'm the team skepticism for two reasons, or for three reasons basically. First, especially with the commonly used tools like ChatGPT, Bard, and whatever Lambda, the problem is we do not know the training data. It could be that it's only trained on diabetes, but we think it gives us a false feeling for confidence and trust, which it shouldn't have. As you said, it makes facts up. We heard Jordan Peterson the other week in his podcast talk about that he asked ChatGPT a few things, and it made up scientific literature references which did not exist at all. And I think that's the same risk. And I fear really a lot of doctors already using ChatGPT on night shift when they are under stress. And as we don't know on what medical conditions and what ethnicities and site conditions it was trained, we don't know how reliable and trustworthy the results are. Second, data, right? If you don't train your algorithm properly, you don't get the good data. If you give him only a few data points, there's a bigger variation. Then that really scares me. There is no label on ChatGPT or Bard telling us, for what it can be used in medical context. We don't know if it was ever validated for medical context. And as it's learning a lot constantly, it's really constantly retrained and retrained. There might be biases we don't know, and that's a black box we cannot look into. And I'm very much afraid when you think about the Gauss curve, the normal distribution, that especially in the range of 3 sigma, that's 5% of the population, that they might have a special condition or extraordinary circumstance which the AI is not trained for, and now they are treated or diagnosed with the same tool which is not properly trained. So that's number two. And third, I think we don't with software. There's a problem because you can't really enforce software, right? Authorities like the FDA or NMPA in China, for example, or in Europe, the European Commission, you cannot hold software at your border, right? Because of the app stores, everything is available immediately globally for every person, basically. And we don't know yet, right, what it would need to cover the world's population in one tool. Is it 100,000 training data points? Is it 5 million training data points? We don't know, right? So what is good for like me, a male white, right, might not be good for a young woman in China. We just don't know. We don't have experience yet.
There is another problem in the United States. These companies, health plans, and healthcare system, they don't want to release the data to anybody. They're holding the data because it's the other guy will compete with them or whatever. There is no legalities right now. There is no law forcing them interoperability. They're forcing them to release the data. Epic is fighting. Every company is went to the courts. So we don't have any uniform data whether the data is there is really this is without data your AI is going to be very bit challenging, is not?
Absolutely, absolutely. And when you look at the beginnings of AI, right? When the first AI models were trained to differentiate a giraffe from a lion, right? You needed high quality photographs. Now, with medical data, there's a problem. There is not much high quality medical data available. And what people don't understand, it doesn't help if you dump thousands of medical records into an AI. You need to tell the AI, this is a medical record. where this person had a stroke at the end, and now you need an unbiased, much diverse training data set of maybe 100,000, 500,000 people, all genders, all ages, right, for strokes. And this quality data, it's high quality data you need to train an algorithm properly. This is not available. And if it's available, then it's very expensive. Now, all these AI startups, and with all the given respect, I love innovation and disruption. So please go ahead. Everybody who has a fantastic idea should go ahead. But they are usually not properly funded to buy that high quality medical record data. So what we will have is a low quality algorithm out of low quality data. I mean, I don't want to stress the saying, right, shit in, shit out, but that's exactly the point. If you do not have high quality data, your algorithm cannot produce high quality results, as you said. And that's the risk we have currently.
It is a big challenge in the getting the high quality data. The reason is, do you agree with me that AI is different than MI, machine learning, ML? Because AI means you need to have intelligence. You can create new laws like E is equal to mc square. That is the brain of the Albert Einstein created. That is the real intelligence. But this machine learning is not an intelligence, it's a predictive value. We need to understand it doesn't create the new, yet it has not created yet new rules, new therapies, or new drugs. It did not create. It's just predicting the next steps much more clear. Is it that distinction we need to understand? We cannot confabulate some of the AI's drum beats, people who are beating the drums about AI. They need to tell that difference. Do you agree with that?
I absolutely agree with you. And with machine learning, I think, to predict certain patterns, static patterns in a data set, I think that we have already relatively good understanding. But still, both AI and machine learning, they both require high quality data sets, whether you predict a risk score based on existing patterns, or if a generative AI, and I think that's the trend everybody speaks about, that based on high quality data. I mean, the idea is, right, let's assume in an ideal world we have all data of all people worldwide. We know what they have, what condition they have, and out of this you can either extract ML risk scores. You can predict, based on your current age and your blood pressure, you have a 68% chance of a stroke in the next 5 years. I think that we have already relative good. But the idea of the current trend, right, and what everybody talks about is that based on your medical data compared to the rest of the world, in an ideal scenario, they would say you not only have a 68% risk of a stroke, but if you start eating more broccoli today, you can avoid the diabetes you will have in 20 years, right? And if you do eat more broccoli, by the way, you can also stop using your blood pressure medication, because that will help also there, right? Or you can start reducing it now and stop it in 5 years. So that is beyond machine learning. That is combining knowledge of the world into a pathway into your future.
Okay. You know that you wrote an article. I was reading about that article. In that article, you said that the millennials, the Gen Z generation, they trust more 40% than a doctor. Only 20% they trust the doctor. They trust the AI. 46% he said. That's astounding. That's a bad news for the doctors.
And that is not a bad, that is a bad news for the doctors, but maybe also for the Gen Z people, because and I worked myself 10 years in nursing service on night shift, right? And what I learned is there are very good doctors who trust their gut feeling and get it almost every time right. And what we also should avoid is experience. AI only gets experience by the data we give them. A doctor gains experience by the data he has, by the patients he touched, but also by his colleagues, right? So there is a vital exchange between doctors, and I think they talk to each other, and that is what AI does not do. AI relies on data it got fed, and that's it. There's no gut feeling, and that's a
So,
little bit my worry too. That we remove humanity out of a very human and social field of our interaction with doctors.
so there is no, we, there is a skeptics as you are a skeptic. So the government has to have a responsibility to regulating. These are the good ones. These are the safe ones. These are not the safe ones. They need to come up with a strong regulations. Are they have a regulations in the United States? And let us talk about the United States first, and then talk about the rest of the world next.
Yeah, I mean there are already very strong regulations for any kind of software, and that includes AI, and especially if we take the US FDA, for example. I mean, they follow the IMDF, which is the International Medical Device Regulator Forum. So all the authorities come together and jointly define specifics of medical device, and they are very clear. Any software, basically, which is used to treat, diagnose, or help in the progression or alleviation of a disease that could be anything, right, is a medical device. So currently, in all the major regulations, if you look Canada, US, Brazil, Anvisa, EU, TGA on Australia, Japan, China, uh, India, they all say that AI is a software, and as a software in medical context, it is regulated as a medical device. So basically today, when you look into the space, and the FDA did a research a couple of years ago of the app stores, where they found 320,000 software and apps which would qualify as a medical device, but they haven't got the right approval. So currently today, when you look at a compliant software, you need to look, is it registered as a medical device? But why is that important? In these regulations, FDA, as I said, they have a very broad software as a medical device guidelines, guidances, regulation. They have now also a very clear pathway for AI, generative AI, as a medical device. You need to prove two things: that the device is safe, so that the software is safe for the patient, and that it's beneficial. So they require clinical evidence. For
Yes.
example, when we talk about AI algorithms or ML algorithms, which are already approved, you can check that on their website with the US FDA. What they want to see is that it's tested, it is safe, it does not put the patient in danger, and it has been tested to be beneficial, so to predict, diagnose, treat a disease properly. And when we talk about generative AI in the area of FDA, so that an algorithm is constantly learning from the data it gets from the outside. The FDA is moving very similar to pharma into a algorithm change protocol. Um, um, yeah,
To comply with the laws. So let
yeah,
me let me ask you a question. So that's in the medical environment, they are following a process. They are following a process, a streamlined process that is safe and well and good. But these when you have a third party apps coming all over the place, they don't have any. Everybody loads up on their phone, and there is no mechanism to tell them whether it's good or bad. And these guys are believing in those. Don't you think that we need to, government should get in, step in, and put some kind of restrictions? You can't put this overnight. You make it up in the sleep, that you make up an app and then throw into the public. that is a dangerous response. Don't they think we should stop those kind of people to even loading up before? Or
Well,
there are no regulations at all at this time, right?
Well, yeah, I mean, as I said, there's everywhere there are the medical device regulations. So essentially, when you look at that, you should not be able to place a software on the market without having it properly approved or certified by the local authority. Now, the problem with software is you can't hold it back. As you said, everybody can upload to the app stores, and physical medical devices you can stop at the border in customs, but software you can't hold back. And the problem is, and many authorities have tried to stop software from being uploaded to the app stores. The software disappears and reappears a week later. Same software, but different appearance, different name. And I think the main thing is when you look into the regulation, Apple or Google with their app stores and Play stores, they are by definition distributors of medical devices. Now you can hold them accountable and responsible for checking the appropriate certification and medical device approval, but currently that is not happening. So I think the authorities, if they want to keep their people, their population, their country safe, what is their utmost thing they need to do, right? They need to talk to these software providers which act as distributors and stop them of making medical devices available which are not appropriately certified and approved.
That's absolutely true. So they can make it accountable. Some people who are like the hosting of the servers, those kind of people, Google and big companies, they should be responsible. Putting before you put on this your platform, you're responsible to check their proper licensing credentials. That's one way to stop. There's a lot of crazy stuff coming on the things, and then they say that you're feeling good, that, and even though he's depressed, he's feeling, oh, you're feeling good. So they can do the wrong conclusions, would not be available, would not be that you're not putting the patients or the public in general at health risk. So
No,
we have to be
absolutely, yeah.
very careful about who are putting these kind of things. That should have regulations, clear regulations, both in the United States and everywhere in the world. They don't exist at this time, right?
The regulations exist. The regulations exist indeed, and very good indeed. When you look, for example, China has put out at the end of 2022 very good AI and software regulations, where in one of their technical review guidelines, they very clearly state that importers of such a software, which includes AI, need to make a clear risk management activity, or need to provide that risk management activity to show that the differences for the AI tool between Chinese and foreigners in terms of ethnicity, epidemiological characteristics, clinical diagnosis, treatments, and so on. So they have very good regulation. The problem is that as long as it's available, but just by a click, right? Nobody will be able to enforce these regulations. So the regulations are in place. They are very strict for medical context, for clinical context. So every software or AI or ML tool is already regulated today. We do not need to wait for the EU AI Act. There is the EU MDR, for example, in the EU. So every country currently, and we see that when we register products, there are regulations in place. The problem is that they are not enforced, and as long
They
as
need
there
to
is
be
no
enforced.
they
Sorry to
need,
say that,
yeah,
but they
yeah.
need to be enforced, because you cannot have a Google in the China. So you can enforce, they can stop a Google, they can stop anybody else,
They
that's
can,
much
yeah.
easier.
No, they can, and we could in Europe too, but we would need to step up and say it is required. And to be honest, when we look, and to be fair, credit to Apple, when you look into their Apple Watch, it is CE marked, so they know the medical device regulation. They know that there is
Yes.
a regulation to be followed. The problem is that the European Commission is not yet stepping up and enforcing the distributor's obligation. Even the regulation for a medical device distributor is already there. But it's not enforced. In software, it is not enforced. For hardware, when you sell a blood pressure monitor and you are the distributor, oh yeah, it is enforced.
So,
But for
so
software, it is not.
so the policymakers have a little bit of understanding problem of these people like you need to educate these policymakers, the politicians. They need to have some understanding. We need to offer some courses and some kind of a training program for all these politicians and policymakers to understand, to deal with this kind of a. That's what I see. There's a lot of these people, they don't understand it. So that one of the
Mm.
senator was saying, I don't understand anything at all of what I wanted to enforce it. That is a big challenge. We need to really, people like you need to educate a lot of these policymakers and politicians. Do you agree?
Yeah, I mean that is one problem, that the understanding is not there. The other problem is we every day work with our smartphones, with our tablets. We are so used to download apps and do not think about data privacy. We do not think about cybersecurity.
Yeah.
We do not think about medical device regulation. We just download it. We got used to that convenience, and now for the first time, where we see the risk, where we feel that there might be patient safety affected, we do not have a way to step back from that convenience and gain the understanding and enforce what is already there. It would be easy to enforce, much easier than blood pressure monitors, which you
Yes.
can send via DHL. Nobody will open the package. So distribution of hardware is much more difficult to stop and to enforce than distribution of software, because distribution of software, to be honest, the majority of the market is divided by the four big providers: Google, Apple, AWS,
You
and
could
for example,
enforce
Oracle.
easily.
It's
You're saying
easy.
you
It's
could
just a
enforce easily.
button. It is just a button. You need to put someone in the headquarters or in the European branches, and it's by far easier, right? The servers
When I
are
come back, I'm
there.
going to present some topic, symmetry. After I come back, we'll talk about a little bit about the regulations, in the future regulations, what are going to be in the United States and China and India. What are the possible regulations for the AI, and then protect the public health. That is the most. And then we can talk about medical devices also a little bit. When I come back, let me present my topic today. That is a Rudolf Wagner from Human Global Director. He has a lot of experience in the AI and everything. So let me talk about the I'm going to present a topic about the laws, about symmetry laws, different kind of laws. See, with the natural laws of nature. So me and Rudolph are going to watch in the side. I'm going to put him. Okay. So let me talk about the symmetry of the human. There's a lot. Da Vinci's diagram is a very famous diagram. It is actually bilateral symmetry. It is showing two hands that are equally left side is equal to the right side. He's showing that he was Leonardo da Vinci is first introduced this bilateral symmetry concept from Italy. So that is a symmetry of the human, is a very important, embedded in the nature. But the laws of symmetries are both the biological, in the medical you see, in the biological you see butterflies, and the both sides are the same, the colors and everything is the repeating. The mirror image of the left side is the right side. That is a bilateral biological systems create automatic. And the medical system in the lungs, and if you see X-rays and everything, see the left side lung is the right side lung. They're all very similar in the bilateral symmetry. In the structural side, the if you say snowflake, it is a structural symmetry that you see very much. If you to rotate anything at all, that's kind of rotational symmetry they call that you see. In the functional symmetry, that's actually the movement, how you move, what you move. Even the movement is also, it has to be a loss of symmetry. I will explain you what symmetry is. It has to be coordinated, and both sides there are several symmetries. I will explain. but these are the important symmetries. I tell you why they are important. So one of the facial symmetry that some of the people say that people are beautiful people, the beauty is assigned. Some of the studies are done in different universities. The facial, some people attractiveness is assigned to the bilateral symmetry of the face. If you draw a line between the eyebrows, if the left side is equal to the right side, that's what they call bilateral symmetries, or bilateral. They are more beautiful. They're more attractive, they say. So it's actually, they've done a lot of research on it. There's quite a bit of impressive statistics there. So the bilateral symmetry is the facial symmetry, structural symmetry, and functional symmetry. For example, the woman have more orgasms, in fact, with the man with the structural symmetry, with the bilateral symmetry is much more prone. They have much more engaging with the man. The reason was that's a healthy is the good sign is that if the left side is equal to the almost looks like a right side, it creates a health and all the other things. That's why it's a good health and good genes it represents. That's one of the things. So structural symmetry is important to selecting the mate. That's why so women get much more excited about the people with the man with the bilateral symmetry, particularly for women. He's done the research in the University of California, University of Pennsylvania, and the Toronto. They made us quite a bit. Even the animals, even the flies, honeybees prefer beauty, radial symmetry prefers. So it's actually it goes to a flower not just for honey. It goes to a flower which is radially symmetric, very symmetric nature, geometrically symmetric. It does. That is a symmetric breast, for example. As you know, the breast cancer is one of the threat to the humanity. 1 in 8 women, 12% by the time they live up to 80 years, they're going to get the 12% of the women get the cancers. Out of 10, 2 3 people are going to get the cancer if they live long enough to 80 years. 1 in 5 cases. So that is under 50. They are actually under 50 right now. The 20% of the diagnosis, 20% of the diagnosis so far under 50 right now. That is a very threat. African American women are about 1.5 times more prone to the breast cancer, and Hispanic women is 1.2 times more prone to the breast cancer than white women. So they did quite a bit of a research on the asymmetric breast, a breast which is not a left side is not equal to the right side breast, different sizes. The reason in Memorial Sloan Kettering cancer, John Hopkins, University of Toronto, they did a research. They're prone to it's not the only factor, but that's one of the factors is asymmetric breast is prone to the raising the risk of cancer actually. That is a lot of research is done. And also fear of asymmetry. Asymmetry is not exactly the same. Left side is not equal to the right side, or it is not, when you turn around, it doesn't look same. So this fear of symmetry, obsessive compulsive disorder is assigned to the actually is fear of asymmetry. If asymmetry means left side face is not right side face is not equal, then you get the fear. So the asymmetry creates a OCD. A fear of asymmetry is causing OCD. Is a evolutionary genetic disorder, not a behavioral disorder. That's what they're finding out. Is may not be behavioral. This is educational purpose only. You have to go to the doctor. Don't take this as a final analysis, but you need to consult anything with the doctor. But anyway, that is a fear of asymmetry. Is the OCD, obsessive compulsory disorder, is the evolutionary genetic disorder. It came from the savannas of Africa. We are all afraid of anything asymmetric. So that came from there. So that is an evolutionary genetic disorder. So people with OCD, it may not be. It is maybe much more bigger problem than just a behavioral problem. So fear of asymmetry is if you see in the movies and the Frankenstein and the movies you see, and the left side doesn't look the same as the right side. They have a very asymmetric faces. that creates a lot of fear. We all, Frankenstein and all those people, do get a fear because of the symmetric faces. So the nature has a symmetry, follows some symmetric laws of symmetry. So, for example, the diamond has a perfect symmetry. That's a very good symmetry it follows. The flowers is a radially symmetric. If you turn around the flower, whichever way, this exactly looks same. The same thing with the plants. So the nature adopts symmetry quite aggressively. As you see everywhere, symmetry, nature adopts symmetry. It follows the laws of symmetry. But so now let us talk about something different. Before I get back to the symmetry, laws of symmetry, Einstein got a problem. What problem was? The law of conservation of energy. Energy is neither created nor destroyed, is always constant in the nature, constant in the universe. But when he was doing expanding universe, the energy conservation is not holding good. So he's violating the laws of conservation of energy. Energy is neither created nor destroyed. It is increasing. The law of energy, the energy is increasing while with the expanding universe. So Einstein got a problem. Then, as usual, woman came to rescue. That is from the Germany. She went to school in Munich. She's same place as Rudolf Wagner. Her name is Emmy Nether. She came up with a profound law. She said that energy is not a fundamental. Geometry is fundamental. The beauty is fundamental. She's a mathematician, trained in math. She has a PhD in mathematics. She said that, actually what Einstein is wrong is that energy is not fundamental. Geometry is fundamental. That is where you start. That the laws of the universe are based on the geometry, not on the energy itself. The energy is incidental for the incidentals, energy and other the things. So the laws of symmetry, for example, time symmetry, the conservation of energy comes from the time symmetry. Time symmetry means if I throw a ball up, it comes down today, yesterday, today, tomorrow. It may look silly for you, but that law actually translates into conservation of energy law. So this law is a more sacred. The time symmetry is a more sacred than conservation of energy. Universal law of time symmetry is one of them. I'm going to play a video. It will talk a little bit about symmetry, a little bit. It will explain to you a little bit better than me. So watch this video.
Look into a mirror, wave your hand and your reflection will wave back at you. In everyday life, it's easy to take the effect of symmetry for granted. But symmetry is vital to understanding and predicting how our universe works. This relationship between symmetry and the mechanics of the universe was something Emmy Noether proved in 1915 with her remarkable theorem, linking maths and physics in one harmonious statement. Wherever there is a symmetry of nature, there's a corresponding conservation law. So what exactly do we mean by symmetry in physics? Well, it can be described as a transformation that leaves a system fundamentally unchanged after the transformation has been performed. It's a change that makes no change. Take, for example, spatial translation. If we have a system and move it to a different point in space, that system would continue to work in the same way, provided all of the relevant conditions of that system were moved along with it. In other words, the laws of physics are not affected by translation in space. And similarly, with time translation, a system can be shifted at any point in time, and its physics would remain unchanged too. Even the most fundamental laws of physics are themselves symmetrical. They remain the same wherever or whenever you are in the universe. The symmetry of time translation confirms to us that energy cannot be created or destroyed.
The laws of symmetry comes from there. So that is explained. The transformation of whichever way you transfer that kind of things, it creates the symmetry. It should remain same. That's a lot of if you change around that is actually one of the symmetry violations. Is our universe was matter and antimatter. One of the symmetry violations they say. But basically, that what the symmetry is. So the breast cancer, the people use the surgeries in the detection side. I told you that asymmetric breasts are more prone to the cancer. You can detection side, you can use a symmetrical loss of symmetry, mathematics she created, and the reconstruction. When you are doing a reconstruction, you can do the mathematics of the symmetry, loss of symmetry, to create the reconstruction in the breast augmentation. In orthopedics, surgery, same thing. Prosthetics, if you create a prosthetics, you have to follow symmetry laws, because you have the two legs or two hands. You have to follow the same laws. So they're quite extensive in medical field. Functional symmetry, for example, injury prevention. People walk around, or you're running around the wrong way, that can create injuries. So it is symmetry. There's lots of symmetry out there. You can train them how to move, how to do that, and reduce the injuries for the players, improve performance. Same thing, you can use a loss of symmetry in the drug discovery, in the protein folding. What are the laws it's following? What kind of symmetry it's following? Molecular integrity, at least. Those are all drug discovery time. You will find out symmetry, loss of symmetry play a vital role. The next one is the fractal symmetry of the mind. If a psilocybin, if you take a mushrooms, people see beautiful things in the completely visual stimulations, visual audio stimulations. They are basically following a lots of symmetry, fractal symmetries they're following. You will see the visual simulations of the fractal symmetries. So nature's wonder, human body is a very universal laws. We follow it's basically as a nature's wonder. That is, the human body it came from the laws of the nature. Those are so that is the laws of nature came from. A lot of companies are following the symmetry algorithms. Posture Co, 3DMD, Vicon, and Megvi from China, and Colossus. They're all symmetry algorithms they manage. And algorithms, Rudolf knows a lot more than I do. These are the algorithms based on symmetry, lots of symmetry, and lots of mathematics, symmetry, matrix, and all those things. They follow that. That is there are a lot of companies work on the symmetry algorithms. So eventually, that's in the medical field is it's a very evolving field. It's a very new thing, laws of symmetry applying to the medicine. So for that, we need to credit another. She is the one who said that the geometry is so fundamental. Laws of symmetry are fundamental to the nature. We need to understand them better and more clear. So when Nather died in 19, she moved to Philadelphia, and then she died. She was working as a professor at Bryn Mawr College near Philadelphia, and she died there in 1935 with ovarian cancer. So her ashes she was cremated. Her ashes was spread out across that in the footpath around there. So still her ashes were there. So when Emmy Noether died, Einstein wrote in the New York Times, Noether was the most mathematical genius thus far, mathematical genius thus far produced. That's what he said. He called a genius. Einstein called Emmy Noether as a genius, a woman who never really got a good recognition. She's totally wonderful. She came for a few. She was borrowed from mathematics to physics, and she gave the wonderful laws of the nature. She gave the tools today we can use for the breast cancer, breast surgeries, and in the sports we can do that thanks to Emmy Noether, a remarkable woman in the history. Thank you for watching, and let me bring yes. So that's a lot of symmetry. That's a lady from your town, Munich. She was a professor there.
That's wonderful. Emmy Noether has a also very traditional Bavarian first name, Amalia, and she's from Erlangen in Bavaria. Wonderful. I think it's a very good presentation, and I think symmetry will play a role, whether it's with breast cancer detection, but also we know that, for example, eye movement or differences, for example, in the eyes, can also be used to predict diseases. So that was a wonderful presentation. And I think Emmy Noether is a very unknown person she played a fundamental role in many things. She constructed many mathematics, and it's wonderful that you brought her up, because I think many people do not know her, which is a shame.
Yeah, we shame. Thank you so much. But Rudolf Wagner. So Rudolf, tell me about something about what you're planning to do. What do you think of AI regulations are going to be in the future? What are the things that looks like in the future? What we should do without data? How do we control patients, doctors, and health systems? How they adopt the AI in the future?
Yeah. I think one thing we cannot stop, right? Because when these tools now, ChatGPT is rolling out their native smartphone apps across the world. I think one thing we cannot hold back, and that's the use of these large language models in clinical context, in hospitals and wherever. I think what we can do is educate clinicians, physicians, doctors across the world about the limitations and the watch outs, because when you use such unapproved tools, the doctors are always off label. That means that the full liability is on them. So anything the AI gets wrong, they get wrong. So I think education is one piece, and I think we will see also from the regulators much more education for the clinicians than we see now. The second thing is, and we've seen that in the past, that bodies like IEC or ISO, they are very quick in developing standards. So I think we will see, we have already 62304, so IEC 62304. We have IEC 62366. These are product standards on software development for medical devices, or man-machine interface ergonomics, 62366. So there will be product standards from ISO and IEC on AI in medical context. So we will see that ramping up. And last but not least, I think we will see enforcement actions one day. I hope rather sooner than later, for AI tools. So I think the authorities will step up latest when we unfortunately will have the first scandal, right? That something went massively wrong with an AI tool by misdiagnosing, mistreating. Then I think we will see the authorities stepping up. But also, on the other hand, the pressure from the industry, where more and more predictive algorithms are developed, more and more AI tools, generative, self-learning, constantly self-learning AI algorithms will be developed. I think we will see also that the regulation is moving alongside. I said already, we have the medical device regulation globally, but we will also have a regulation. I think the FDA and China are a little bit ahead of the game there. So what does the manufacturer, so the programmer, really need to show in terms of opening the black box? So what is the AI learning? What data does it consume? And what does it mean in future in order to keep patients safe? So I think we will have these three pillars: education, product standards, and the regulation for medical device ramping up.
I have a question for you, Rudolph. Suppose the people are making up stories. They say my fraud things, they're like, "Oh, some of the medicines don't work, but they say it works, or it treats the cancer, it cures the cancer." So AI is also learning the wrong things. How do you stop that?
Absolutely. Yeah. And it's making up stuff. I mean, there's a risk of false negatives and false positives, of course, right? Yeah. I mean, the
Yeah.
AI can also really, and I mean, we have already the saying of Dr. Google. I mean, people are Googling today already their symptoms, right? And the AI will just make these things worse. That the AI, and we know that AI, these large language models are making stuff up. They are inventing, they are predicting something which is not there. And I think, when an AI makes up a literature reference which does not exist, citing a scientific paper which does not exist, I think, it can also make up a new disease. I mean, maybe we see new diseases, right, which do not exist, but the AI is just fabulating and hallucinating about.
Yeah, that's one thing you wrote about it. It's a very danger to the confabulation. It's actually making up a story, because then you're learning the fraud system and say, oh, so if you eat a grass, wild grass, it cures cancer. It is then you have fraudsters really ruling the medicine. That could be a danger from AI. Could learn, oh, there is a place you can go to into the Costa Rica, they can cure cancers. They can make it up, all the stories. Yeah, I can learn all these wrong things also.
Absolutely.
There's a danger to it, and then we need to have some enforcement of laws, and in this was nature required, right?
Absolutely. And I mean, we didn't speak about that, but there's also, I mean, when we think about that, modern warfare happens in the virtual area, right? Where digital tools are used against populations. I mean, you can think of that certain AI tools are trained intentionally wrong, so that maybe, right, people who have basically a disease might be
Yes.
diagnosed perfectly healthy. Even in the criminal space, I would say, or with criminal intentions, you can bias a AI tool just by training it the wrong things. I mean, it's easy. You just tell, no, these are all not cancer patients, but in fact they are cancer patients, and suddenly the AI will not detect cancer anymore. It's possible.
Rudolf, they want to reach you. What is if they want to learn from you a little bit? You're very good. You really gave a very good roadmap, and then your articles are wonderful. Actually, all the
Thank you.
doctors, I highly recommend to read Rudolf Wagner's articles in there about how that the healthcare and this AI relationship and how they should be managed, and it gives you a kind of a roadmap for you, all of you, the doctors and the other healthcare companies. So, Rudolph, how would they reach you, and what is the website for you, or anything like that?
The best is LinkedIn, Rudolf Wagner. That's the best way to reach me. I'm every day very active on LinkedIn, and you can reach me there. That's the easiest way. Or you contact Ramana, and he has my details too. So either way, I'm fine with it.
Thank you. It's a truly an honor. It's a privilege to talk with you. And if you can stay for a few minutes, I can talk with you a little bit more after the broadcast. But it is a
Absolutely.
truly an honor and privilege, and it's educational for all of us. We need this kind of education more and more of how this AI is interacting our lives and controlling our lives, and particularly related to health. Is a very vital important. Thank you. It's truly an honor.
And same back to you. It was an honor to speak with you and see your Amy Noether and Symmetry. Very important. And it was a pleasure to be with you tonight.
Thank you. Good night.
We are retelling their stories through our patented designs that can be worn on scrubs, t-shirts, printed on conference bags, and endless other promotional materials. Daily Wear for Medicine is the first ever of its kind to create curiosity in medicine through visual art. We at MedBricks are celebrating unsung heroes of the past who made enormous contributions to the field of medicine through our unique campaign called Daily Wear for Medicine. You can wear it, carry